All right, our discussion today is centered on the characteristics of a lamp when it is connected in an electric circuit as shown. This schematic diagram shows when a lamp is connected, what happens, what kind of characteristics we are going to obtain between current measured by ampere and voltage measured by voltmeter, right? So before we delve into all that, it is important for us to understand the various parts of this schematic representation of an electric circuit, especially when a lamp is connected. Recall that in our previous video we discussed an electric circuit when a resistor is connected, right? So today we are going to compare what happens when a lamp or a bulb is connected in an electric circuit. So the first thing we need to do here is to understand the various components that have been put together to arrive at this schematic representation. So the first one I am putting in a square box here is the symbol for battery. That's the source of energy to this diagram, right, or this circuit. Then the second one is a variable resistor that adjusts the values of what it does is to adjust. A variable resistor adjusts, okay, varies the values of voltages, okay, obtained, all right, from the voltmeter. And then we have the lamp. This is the symbol for the lamp, okay, very good. Directly above the lamp is the symbol for voltmeter, okay. And then you can see that there is a connection between the first terminal of the lamp and the second terminal of the lamp. So the voltmeter is connected in what I call parallel with the lamp. I repeat, the voltmeter is connected in parallel with the lamp, not in series. Please take notes. All right, good. Whereas the last, not the least component, is connected in series with the lamp, and it is called the ammeter. The function of an ammeter is to measure the amount of current flowing in the circuit at a given point in time. So it is connected in series with the lamp, while the voltmeter is connected in parallel with the lamp. That must be taken into consideration. All right, now we have understood the various parts of this schematic representation of an electric circuit. It is time for us to go into more detail and see what we are going to obtain. We are going to see the values we are going to obtain by the time we arrange this circuit like this. What values are we going to obtain from ammeter, and also what values are we going to obtain from the voltmeter respectively. Before we go into all that, it is time for me to seek your support. Subscribe, all right? If you have found value in what I'm doing in this lesson, I urge you to subscribe. And then share with your friends, share with your students, share with your numerous networks, all right? Share with anyone that likes learning, that loves learning. Very, very important. Don't forget to turn on the post notification button so that each time content like this are uploaded, you will be among the first set of individuals that will be notified. Do not forget to give us some thumbs up to increase so that the YouTube engine or search engine will recognize this video to other areas. All right, don't forget to give us some thumbs up, some likes. All right? Thank you so much. My returning subscribers, my new subscribers, I am so proud of you. All right, having said that, let's move to the next slide that has to do with values obtained. Like I said earlier, values obtained from the voltmeter, that is the potential difference across the two terminals, or 0.5, 1, 1.5, 2.0, 2.5, 3.0, 3.5, 4.0, 4.5, 5.0, 5.5, 6.0, 6.5, and so on and so forth. Each of these potential values, okay, produced 0.1 values on the ammeter. All right, from 0.1 to 1.3 to 1.31 amps. Very important. So with these values, we can now plot a graph and then see what it will give us, whether it's going to give us a curve or a straight line relationship between voltage and current. That's what we are interested in. We are interested in knowing what happens if we plot these values. All right, whether we are going to get a curve or a linear relationship between voltage and current, or between current and voltage. Don't forget, subscribe, right? Give us some thumbs up, share with your friends, with your networks, with your students, with anyone that likes learning. Learning is a continuous process. Support this learning platform. All right, let's see the characteristic we are going to get. Boom! We have a parabolic curve. A parabolic curve. So what happens? Our evaluation here says that when a filament bulb is connected, the current does not increase. Take it again. When a filament bulb is connected in an electric circuit, the current does not just increase as fast as the potential difference. No! What happens is this. As the amount of energy is doubled, all right, does not actually cause a double in the current value. No, does not cause the current to become twice as fast. No. The more energy that is put into the bulb, look at it, the harder it is for the current to flow. I repeat, look at this very important statement. The more energy put into the bulb, very interesting, the harder it is for the current to flow. The resistance of the bulb increases. So the more you pump energy into the bulb, the harder it is for the current to flow, because the resistance of the bulb will also increase. We need to know that. As the potential difference increases, take it, as the potential difference V increases, so does the temperature of the thin wire inside the bulb. That's the filament. The bulb contains a small, tiny thin wire. So if you are increasing the potential difference, the temperature of that thin wire also increases. And what happens? There will be what? Corresponding vibrations of the ions that make up the thin wire, which makes it harder for the electrons to get past. So that's what happens. If we understand this, of course, we will expect something like this. We will expect a characteristic like this. Look at it. A wavy curve, right? Or a parabolic curve representing the relationship between currents in amps and then potential difference in volts. Thank you so much for watching. Thank you for watching up to this moment. And I urge you once again to subscribe. Just give us some subscription, all right? Give us some thumbs up. Support us by sharing with your networks, with your students, with your friends, with anyone that likes learning. Learning is a continuous process, and we will continue to do it for the learning pleasure of those who want to grow academically. All right, having said that, In my next slide, we are going to discuss how this will play out if